There's a short explanation on how to use a database map to help you write SQL queries. This is an example of a map, and it's an example that you will need to create for yourself. It shows the different tables and some extract of the values that go into the tables. Now, it's important to say that it can only be an extract. The number of journeys, for example, is far too large to show on a single screen, so you just show an extract of those. It's also important to say that I've only drawn on some of the relationship lines. You will need to draw in all the rest. But already it should be very clear as to the value of drawing this map. It shows you the tables and the column names, but you can also quickly see the sorts of values that go into there. So, for example, when it says passenger seats, it's not clear what sort of value there is there, whereas you can see figures for the values. Or let's take this one when it's talking about the journey date. What format is the date? Well, you can see it here. Or when it says fare, what values can typical fares be? And there are some examples here. But the really big advantage of drawing a database map is when you come to write SQL queries, because when you need to join different tables together, you have already thought through how different tables relate. For example, let's take the journeys and the drivers. You can see here a list of all the, well, some of the journeys, not all of the journeys, and you can see the key of the drivers for those particular journeys, the key or the identifiers of the drivers. And in this table, you can see a list of drivers, and you can see that some of them have got exactly the same value. So, for example, driver 0000, you can see which journeys they've made. You can see 2 of the journeys here. For driver 1, you can see some of the journeys that they have driven, and you can look up the name of that driver or where they are normally located. And this is because the primary key of the driver, the identifier here, is the same as the foreign key here. So the line that I've carefully drawn in shows the driver identifier being used here. It matches drivers using driver keys here. And when they match, these two can be joined together. Let's give an example of that using SQL. And our intention will be to get a list of driver names, which cars they have driven, and what fares they have taken. Can I just repeat that? It's going to be the driver name, the car registration, and the fare. So let's start with this table. Well, in fact, let's start with the SQL and put in those 3 columns. So let's put in select. And which 3 columns? It's going to be the driver name, the car registration, and it was going to be the fare. So in the top line, name the columns that you're interested in. We then have to select one of the tables. So which table are we going to select it from? Let's take it from the drivers table, and we're going to be linking it to the journeys table. So TBL drivers. and we'll do a join to the journeys table. Now, having named the two tables and the columns, we have to say how the link is formed. So we need to name both ends of this line that is in black here. So it's going to be the drivers table, driver primary key, link down to the journeys foreign key. Let's put that in. I'll do a little bit of indentation, although that's not essential. I find it most easy to follow is if you are trying to link two tables, as soon as you put the second one in, repeat its name. So copy that one again and find the driver mentioned in there, the foreign key, and link that to the first table and the equivalent name there, driver's primary key. Okay, so let's go that. And there we are. We have the driver name, the car reg, and the fare, and it lists all the different journeys that there are. A slight refinement on that would be to list the driver's name and the car, but the total fare collected by that driver in that car rather than each individual one. So let's go up and change that. And for this, we're going to want the sum of all the different fares. However, that isn't quite complete yet, because at the moment it's still listing every single journey, with what we'd like to do is combine when the particular all the records for a driver in a particular car, add all those together. So we need to do group by. A group by we want to group on all the columns that are not getting added up together. Let's try that. There we are. And go that as well. Oops, when I can see go, there we are. Great. So now what we have is the driver name, which car they were driving, and the addition of all the different fares that they took within for that particular car. I notice here it calls sum of fare. We could fine tune that a little bit by putting an alias here as let's call it. I'm going to call it total fare would do, and it's changed the column title. Great. Now let's go on to a slightly more complicated example. And in this one, we're going to look at the sort of driving offences that each of the taxi drivers may or may not have had. Let's zoom in on this a little bit more, just so you can see what's going on a bit more better. There we go. So here's some extra tables. We've still got the list of drivers and their driver names, but we've also got a list of different offences that drivers might be able to commit. So, for example, there's speeding, going through red lights, having worn tyres, and so on. And each of these, of course, has a foreign key. Missing from the screen print, this should be the primary key, so there ought to be a PK there for primary key. So these are the identifiers of these different types of offence. And then there's a list of which drivers have committed which offences. And we can do queries where we will be able to link the driver's name to the type of offence they've committed by first looking up the driver's primary key, and using this link to be able to get to this table. So, for example, to join, we can see driver 2, Crack Caddy. We'd be able to pick up Crack Caddy's name. So driver 2 has committed offence number 4. So we could follow the offence down this link to get to what 4 is, which is red lights, has driven through red lights. So it's really important that you prepare a database map which links or shows how the different tables link together. And once you've done that, writing SQL queries is so much easier. Let's have a go at linking the driver's name to the type of offence that they've committed, to which we're going to have to do an inner join to one table and then a second inner join here. Before we get going, I'm just going to type out the standard framework for any query. It's always select and then some column names from a main table, inner join to the secondary table on what is the exact link. So we said that we wanted the driver name and we wanted the offence. Let's look at the name of the title. Offence type. What is the name of our main table? It was table drivers. What are we joining to? Now, in the first instance, we're following this red line from the drivers table through to the offences table. And it's going to be joining it on the driver primary key to the driver foreign key. So table offences is what we needed here. To table offences on. Now, as soon as you've put in table offences, put it back in again. And take the driver, and we're going to link that to the first table, to the drivers table, and find the driver key. Great. So we've now linked the first line, and we could go on to the second, which here is in green, and this is going to link to the offences types. Let's put that in. So I'm going to do another the offences type on. Yeah, indentation isn't important, but it just helps you understand what's going on. As soon as you've typed something in, put it back in again, table offences type, and it's going to be take its primary key. And what are we joining it to? We're joining it to the offences table. So we're doing both ends of this green line. Table offences, and which field? It's going to be the foreign key of the offence type. And let's try running that. Great. And we end up with this guy had 2 offences, this guy had 2 offences. If we go back and look at the offences table, we can see that's true. We can see that the first person had 2 offences, the second person had 2 offences. But using the database map, instead of just printing out this table, well, it's up here, isn't it? Instead of printing out this table, what we've done is collected the name by following the relationship, and we've followed the offence type by following the relationship. So what we're trying to emphasize here is how important it is that you construct a database map which contains a screen print of the table column names, but also some samples of the values. Then it's your job to show how these connect. You don't have to use coloured lines, I've just done that for teaching purposes, and there are a whole bunch around here that you are going to need to fill in. When you write an SQL query, you can say select column name, column name, column name. So you list all the different columns. Then you say from, and you name one of the tables. Then you say inner join and name the next table that's linked. On this value should equal that value. For example, let's say we'll take D002, 0002 should be the same as D002. So you can join these two on that value. When you've done that, you can do another inner join, and this time you would be naming this table, and you would be saying that they are related. The inner join is based on the driver primary key equals the driver foreign key. And since we're also needing this table in, you would then have another inner join that says they are related. This is related by its office type primary key is equal to the office type foreign key. Now, in this explanation, I might have sometimes given the relationship the other way round, naming this second table of the first or vice versa. But since they're equal values, it really doesn't matter which way round you name them on the on clause. Because they're equal, it's got to be the same thing. So, over to you. This really ought to be, for you, to show how essential it is that you use a database map to help you write SQL queries.